Hey, this is OXDF, and today we're looking at Advent of Code 2022, Day 19, Not Enough Minerals. And this will be different than most of the videos I've put up this year for Advent of Code because I've already completely solved it, and I think I started recording my original solve, and this one's hard. I mean, it took me a couple hours, and it's just, I don't think it'd be a very good video, so I'm going to do more of a recap kind of video for this one. I'm still going to go back and try to write the script from scratch, but so maybe we'll make some mistakes along the way. But let's take a look at the challenge here. Story stuff, blah, blah, blah. So we're going to get a handful of blueprints, and in the actual input, they're going to be one per line. But here they break them out. And each blueprint describes, there's 4 kinds of robots. There's ore, clay, obsidian, and geode. And for each robot you have, it makes one of that thing each turn, or it mines it. And each turn I can build one robot. So I can build, if I have 4 ore, I can build another ore robot. If I have 2 clay, I can build a clay robot. If I have 3 ore and 14 clay, I can build an obsidian robot, and then, etc. And the numbers are going to change, but the inputs, so the obsidian is always going to require ore and clay. The geode is always going to require ore and obsidian, just different numbers. So I've got 24 minutes. And so in each minute, I will collect something and then optionally build another robot. So you start with 1 ore robot, and that's it. No minerals. And I think that is about it. Basically, they're going to give us our list of puzzle inputs of blueprints will be our puzzle inputs. And going down, what they want for us to do is to go through each of them and multiply the blueprint's ID number by the number of geodes that can be collected in 24 minutes using that blueprint. So in this example, ID 1 had 9 and the second one had 12, so that'd be 24 plus 9 is 33. And our puzzle result is going to be 1466. Let us jump over here into VS Code. I've already got this is my script day 19 that I did originally. So we're going to start from scratch though. I do already have the input. Let's take a look at it. We can see here it is 30 blueprints in this case. And all the text is saying the same, just the numbers are changing. So we'll notice that. Okay. Let's start to program it. Let's see. So we're going to start with our lines, and we can do. Let's go ahead and say we're going to do a sum here. So we'll start with part 1 equals 0. Then we can say for I comma line in lines in enumerate lines. What we're going to do is part 1 plus equals I plus 1, so like our blueprint numbers were in order. So the first one will enumerate to 0, I equals 0, but we want it to be a 1, times solve line 24. And so we're kind of done, right? We just got to write solve. Okay, the hard part. Def solve. And then what are we going to take for solve? We're going to take a blueprint, and we're going to take the amount of, I'm going to just go on a limb here and guess the amount of time is going to need to change. So I'll start with that. We're going to do a breadth first search. So the first thing we need to do is parse our blueprint into the data that we need to know. So we will say, let's see, we can even grab, grab blueprint 1 here, copy, paste this here. All right, so we've got this first blueprint. What we really need to do is we'll say raw costs equals, and I'm gonna go ahead and just use the regex library here. So import re. And we can now do re.findAll, and this will just be, let's just get the numbers out. So we'll do /d for digits, plus for 1 or more, and close that, and then on blueprint like that, and that'll return all the numbers. In fact, we can just print raw costs, and we can go ahead and Python day19 vid input.text, and we are with the unsupported operand type for int and none type. This is because we're returning nothing, and it's trying to multiply that by something. Let's do return 1. Okay, silly error. Okay, so here we can see, let's get rid of this print line. We don't need that anymore. Now we can see we're getting all of our numbers. We can pick, the first one, 4, 4, 3, 7, 4, 11, 4, 4, 3, 7, 4, 11. Okay, so it looks like we're parsing correctly. Silly little diversion there. Sorry about that. So now we got raw costs. What we really want to know is what is the cost for each kind of robot. So let's go costs equals, and we'll do that. So the first one is going to be raw cost. So what I'm going to try to do is for each of these is to find a tuple of 4 long like this, where it's the amount of ore, the amount of clay, the amount of obsidian, no, the amount of ore, clay, obsidian, geodes. Now none of them are going to have a geode cost, but we'll just do it to be consistent, right? So raw costs, and this will be 0, 1, 2, 3, 4, 5. Oh, sorry, no. This will be number 1, 0, number 1. So raw costs of 1. That'll be our cost for a another ore robot. To make a clay robot, we would need 4 ore. So we'll do raw costs. That'll be the second number, and nothing else. Like that. To make a obsidian robot, we're going to need raw costs 3 and 4 for ore and clay. So it'll be raw costs 3, raw costs 4, 0, 0. Did I lose my autofill here? Did I mess something up? I don't think so. Okay, let's see. And here we'll have, to make an obsidian robot, or no, a geode robot, we need ore and obsidian. So we'll have raw costs sub 5, 0, raw costs sub 6, 0. And that is going to be our raw costs data structure. So now we can say, we know how much does it cost to make any given robot. We have that parsed nicely. Okay, so next we're going to have to think about what our state's going to be. And we're going to do a breadth first search. So we're going to say Q equals, and we better import from collections import deck. And so we'll say Q equals deck, and we'll say Q dot add. And now we're going to need a tuple here with the time. Okay, and then let's also pass in how many minerals we have currently. So we'll start off with, and I'm going to make that all one tuple so I can handle it easier down the road. So we'll start off with 4 zeros, and then we'll start with what our robots are currently. So remember, we start with 1 ore and none of the other ones. And I think that is all we need. It's a bunch of nested tuples, but those are all going to be fine. We're going to need to track what we've seen, because once we parse something, we don't want to have to do it again. So we can keep that as a set. We're going to want to know what our best is. We'll start it at 0, and we're going to return best. So now we can work there. So now we can do while q. So as long as there's something in the queue, t comma stuff comma robots equals q dot pop left. When we work with decks like this, double-ended queues, we can append, we can pop, but we just need those to go to the same side. So we want to append from one, pop from the other, and that's how we get breadth first. So now we've got this. Now there's a couple things we could do. I'm going to think about this. I'm going to try to think about this actually not in terms of steps, but in terms of what robot do I make next. Sometimes I might be done. I might not make any more robots. Now it doesn't mean T is at 0. It just means that I've reached a point where I'm not going to, let's say there's 3 seconds left and I don't have time to make any more. Like I can make another ore robot, but that doesn't help me at all, right? So I can say at a minimum, we're going to say min geodes left equals, and that's going to be the amount we have right now, so stuff sub 3, plus how much time is left times robots sub 3, right? So however many geode robots we have times the amount of time plus the stuff is the minimum amount of geodes that we're going to get left from our current state. And then we can say if min geodes left is greater than best equals min geodes left. And I could do that probably more efficiently, but this is actually a good place to debug if we get stuck, so I'm going to leave it kind of like that. Okay, so now that's one possibility. So the other possibility would we do something. I guess we could also deal with the base case. So right, so if t is equal to 0, or t comma stuff comma robots in scene, continue. We don't need to do anything else. We already handled this. Otherwise, we better add scene. We better add t dot stuff slash robots into our scene set. So now we know we won't hit this again. Okay, so there's 4 robots we could build. So we'll do a 4i in range 4 because we've kind of been handling the clay is 0. No, sorry, ore is 0, clay is 1, obsidian is 2, and rock is 3, or geode is 3. So the first thing we want to check is, do we have the necessary robots to build this next, right? So like, we couldn't, a geode bot requires obsidian. If we don't have anything producing obsidian, then we're never going to be able to make a geode bot. So we're going to say, if any, well, we'll think about it this way, right? We'll do a robots sub, okay, what's the best way to think about this? We're going to say, for cost in costs of, and let's not make this I, we'll call this resource. That'll help us think about what it is, even though it's really just, it's a number of 0 to 3. But so we'll get the costs. We'll get this row right here, right? And we'll say if cost. So we only want to think about the ones that actually have a cost. And we'll say we better also get the ID of that resource, right? So we'll do enumerate, and this will be like resource ID. Okay, so we're going to get each of the costs. So for thinking about a specific resource, so like we're saying, can we build a ore bot? We're going to say, well, let's get the cost for an ore bot. In this case, it'll be something 000. And then we're going to look at each of those, and we're going to say, if there's a cost, because we don't care if there's no cost, we don't need anything, we're good. For any of the costs we have, do we have robots? Robots sub RID, I guess we want to say equals 0. So if for any, okay, so this will give us basically, for any of the costs that we're going to have to pay, do we have robots in that arena? And if any of these are, or are we missing the robots? So, and if any of these are true, like if any of those come back and match, then we're at a point where we need some resource. We have no way to generate that resource. Therefore, the next bot we build cannot be this thing. Hopefully that makes sense. So we'll say if, like that, then we'll just continue. So this basically says, do we have the bots to get to where we need to be to build this resource next? Okay. So if we don't, we just continue on. We're not going to build this resource. So at the beginning, when we only have an ore bot, we're not going to be able to say the next thing we build is an obsidian bot because we need clay for that. And we don't have clay. That's what that's going to catch. Okay. So now we'll assume we do have all the bots we need. We may not have the resources. We have to figure out how long it'll be till we have the resources. We could just step through one at a time and just sort of say, like, if we have the resources, build the bot. But I think that's going to create a ton of states that we don't want to deal with. So we're going to say wait is equal to, let's see. We're going to say wait is equal to, and we're going to do another list comprehension here. So we need to go through now for each of the resources. So it's going to be the same as kind of what we had before. Let's start with cost for RID, comma, cost in, enumerate, costs, the resource. So for this resource, for the resource we're trying to build, let's get the costs. For each of those costs, we'll get a resource ID and a cost. Now, we only care about this if there's a cost, because we don't care about it otherwise. So now we have to figure out for each of these, how long will it be till we have them? So, right, so for here, cost is going to be the number of this thing we need to build it. So we'll say cost minus, and then we can say how much do we already have. So we'll say stuff of RID. That'll tell us how much we already have. So that'll tell us this right now. We have a thing that will tell us how much is left that we need to generate before we can keep going. Now that's going to be dependent on how many robots. Like that, how long it'll take to generate that will depend on how many robots we have. So we can do divided by robots sub RID, and that'll tell us how many time cycles it'll take. And we're going to want to round that up. So we're going to do math.ceil like that around this, and we'll do it here. We better import math. So this now is going to give us, for each resource, how much time it's going to take to build it. How much time is going to left till we have the resources to build it. So we just want to know the max there. We can do that. And I'm going to go ahead and just to try to make this, I'm going to call it black on day 19-vid. Make this a little prettier to read. Okay, so here we're going to say, what is the wait time? How long do we have to wait? Do we have enough resources for all the resources we need to build this resource? Resource. Okay, so now that we have that, oh, there's another thing. What if we already have it all? What if some of these numbers are negative? We don't want any of these numbers to be negative. So we need to, what's the best way to do that? I wonder, I don't think I can just say, what if we make this, this back into a array, and then we plus the 0 onto it. So now we'll have all of those numbers plus the 0, and so we'll get the max. So if they're all negative, we will just get 0. So there we go. Now we have that. So that's how much we have to wait. And now, so if time minus wait minus 1 is less than or equal to 0, so basically what that says is, if our current time, let's say it's going to take, we're going to have to wait 5 minutes before we have the stuff to build it, but there's only 4 minutes left. Well, we're not going to actually build it, so we don't need to bother with that, right? So if the amount of time it would take to build this is longer than we have, and even if we build it and it ends on 0, it still doesn't help us, so we're going to continue. So now we can start to think about what is our next state going to look like. So we can do next stuff. It's going to be stuff. Let's see. So we're going to do our, we're going to work off across our resources, right? So we'll do I for I in range 4 to hit our 4 resources. And now here, what do we really want to have? We're going to have stuff sub I, like that, plus, and now we're going to have our robots sub I times wait plus 1. So like how long are we, because it's going to be, to make this, we're going to have to wait cycles, and then we're going to have to wait 1 more to actually build it. So that's what wait plus 1 is doing there. And then we're going to have to subtract off, let's see, minus costs for the resource that we're building of I. So what this is going to say is, if we're building an ore bot, it's going to go up here and say, oh, well, if my ore is going to go down by this much, my other ones are going to go down by 0. But we're going to lose that ore there. I think that is what we need right there for next stuff. Our next robots is a little bit simpler, I think. Equals, we'll just say list of robots. Turn into a list, then we can say next robots sub resource plus equals 1. And I think that is good. And so now we can come down here and say q.append. So our time will be t minus wait minus 1. That's fine. Our next stuff, we want to turn that back into a tuple so that we can put it into a set and things like that. So we'll pass back next stuff. And we will tuple next robots. I think we have a working solution. Oh, okay. So we have a working solution. There's an optimization, and this is an optimization I did actually find. I'm proud to say there's going to be one later that I didn't find on my own. If we run this, what we're going to find is it's going to take forever. Oops, I didn't mean to format it. Let's try. Even if we do it with the example input here. Oh, let's see what we got here. What line is that? Line 20. We don't want to add, we want to append. I guess we should let's see if we have any other errors here. Unsupported for string and int. Oh, we better make these, okay. So, right, these costs, it's trying to subtract, where are we here? Line math.ceil. So it's trying to subtract cost minus stuff rid. The cost right now is a string. So we split these things. We have not made them into an int. So we will do list map int like that, and then like that. And now all those numbers will be ints. I made that mistake the first time too. Okay, so this is running, but it's taking a long time. And that's kind of what I expected. If we look at, I'm trying to think what the best way to do this is. If we sum up here and say print robots, and look at the robots we're making over time, we'll notice that we are starting to get more and more like let's look right here. We've got 5, we've got 10 clay robots. We're getting 6 ore robots. And let's think about this for a second. If we can only make one bot at a time, one robot per turn, then the most we could ever spend, start here, for example, the most ore we could spend in a turn is 4 for that, 4 for that, 3 for that, and 4 for that. There's no reason we could ever need more than 4 ore robots because it's just wasted. Even if we chose to build every turn from here out, we can only use 4 ore per turn. So we never need more than 4 ore per turn. So what we're going to do is we're going to come back up here and we're going to add in an optimization here. Where we'll call, let's see, where do we put this? Maybe we'll put it right here. Max spend. And that is going to be, let's start again. For I in range 4, like that. And now what are we going to do for I? So we're going to look at, we're going to go across each of the costs. So we'll say cost for cost in costs. What we really want is cost sub I, like that. And so this will give me, for each of the costs, show me, when I equals 0, it'll show me, give me all of the ore costs. When I equals 1, give me all the clay costs, etc. And so what we really want here is max around that. And so that should tell us the maximum of each of those that we can ever spend. So what we really, then we can come down here and we can say, we have enough of this bot if robots sub resource is greater than or equal to max spend resource. So if we already have enough of these robots that we don't ever need to, that doesn't make sense to build more, then we can just do continue. Now there's a quick caveat here. We don't want to, we can always make more obsidian bots. So we'll say if resource is not equal to 3 and robots is that, then we continue. And that way we will never have more than 4 obsidian or 4 ore bots, for example. And so we can run this now. Oh, we're still printing. Let's see, let's get rid of our print here. Where was my print? Here. We can have this now, we can run, and we get 33, which is the answer. We will try it on input, and it will take a minute. But I think we're in a good spot. Yeah, 1466, so that was not too bad. 1466. Okay, part 2. We actually have 32 minutes instead of 24, which is a huge amount. We're doing this kind of exponential branching. But one of the elephants ate most of my blueprints, so I only need to worry about the first 3. And the other thing is now I don't need to worry about this scoring thing. I just multiply the 3 maximums together. So let's go back here. And luckily we've already set ourselves up nicely here. Since we're going to multiply, we'll start with as a 1. We can say for line in lines, part 2 times equals solve line 32. Now, if I run this, we can solve like this. if I run right now, this right here, it will in about 6.5, 7 minutes give me the right answer. There's a few things we can do to make this better. For one, I can switch to running pypy, which is like, so Python is the C Python interpreter. Pypy is faster, quote unquote. And I don't use it very often, but if we run pypy, I might as well run this while we're talking. If I run pypy on here, it will find the answer much faster. So I told you I did these times already. It took me 6.5 minutes, 6 minutes 36 seconds to run it with Python. Running it just like this will run in 1 minute 13 seconds. So better, like 6 times better, not quite 5 times better. But there's another, and that's actually how I originally solved it. But then in sort of just reading about how other people did it, there's a really cool optimization we can think about that'll make it go way faster. So let's think about that here real quick. If I get down here, what happens when I start building up more and more clay that I don't need? I can get to a point actually where I have more clay than if I spent clay every round for the rest of the game, I still couldn't use all my clay. Well, the fact is, if I've got, let's say there's 10 minutes left, and the most clay I could spend in a turn is 4. So the most clay I could spend is 40. Well, if I have 400 clay or 401 clay or 100 clay, it doesn't actually really, those are all the same. The result is going to be the same. And so what we're going to do is we're going to limit our resources. And we're going to do that by doing, we'll say like 4i in range 3, because we don't actually want to limit our of geodes, our last one we're producing. We will say next stuff sub I equals the minimum of next stuffed sub I. So we're going to have at least next stuff sub I. Oh, no, sorry. We could have next stuff. We're going to have at most next stuff sub I. But we might cut it down to max. Why can't I type? Spend sub I. So like, what's the maximum we can spend times, and what's our time left? It's going to be t minus weight minus. I should probably just put that in a variable somewhere. Minus I like that. And so what we're going to do here basically is we're going to say, what's the most we could spend from the time remaining? If we're above that, we're just going to use that number instead. And where that helps us is we're going to get hit in this scene thing a lot more frequently. We're going to save ourselves having to calculate. We're going to save ourselves having to do branches off of it, and it's going to go a lot faster. I'm still waiting on my pypy thing to return. I told you it was going to take a minute. I wonder if I was lying to you there. Might pause the video and see how long it takes for this to finish. I should have run it with time. All right, since I didn't actually finish that anyway, I didn't time it anyway, so we're just gonna kill it and move on actually. Let's see. So if I've got this stuff in here now, I run this. Hopefully it gets answered pretty quickly. 1466. Oh, whoa! I see the problem. We did 4 line and lines. We're supposed to do for line and lines 3. That'll go. So let's run this now. We'll run this with pypy, and my expectation is this will take about less than 10 seconds with the optimization in, although it's not looking like that. So maybe I've messed something up still, or did I not save? Oh, it came in right there at the end. Let's time this. Let's see what we get. 18 seconds. It's interesting. I wonder also if my OBS is just using a lot of my processor / memory right now, so this might be going slower. We could test that by running it on my original one here and seeing how long it takes, because I wrote down earlier that it took 6 seconds to run originally when I was running it. And now here I am running it with OBS running and doing the webcam and stuff like that, and it might just be eating resources and taking longer. So I think it is, because you can see this is already taking way longer than 6 seconds. About 18. Yeah, so I bet that's just the scenario there. All right, I'm going to call this one here. This was not my best day. I do think the optimization here of thinking about the stuff was a really good one. I think it was Jonathan Paulson, I believe, who's one of these guys who's really competitive on this stuff, who I saw credited for this idea. Really smart. Otherwise, noticing that we just have a limit on the number of bots was also critical. And otherwise not too complicated, but man, it took a lot of troubleshooting, and this was kind of an ugly one. So thanks for sticking around with me today. Even my recap video took longer than most of these. So as these get harder, maybe they're going to be harder. I will talk to you tomorrow. Bye.